Germany's grid is currently stuck in a major bottleneck, with over 700 battery projects waiting to connect. To fix this, developers are being offered a flexible connection agreement, or FCA. Think of an FCA as a fast pass to get your battery project into the power grid, providing you accept certain conditions. In this video, we'll explore FCAs and how you can model this in Gridcog. Once projects reach the front of the queue, which from April will be on a first ready, first served basis, rather than on first come, first served basis, they need to negotiate grid connection terms. They often face a choice: wait longer for firm capacity or accept an FCA as a condition for receiving a connection offer. FCAs are contracts which allow grid operators to curtail a project's import or export capacity in real time, depending on factors such as local grid congestion, network loading, or system stability requirements. With paragraph 8A of Renewable Energy Act and paragraph 17(2)(b of the Energy Industry Act, FCAs are now anchored in law and allow network operators to contractually enforce static or dynamic limits on maximum import and export capacity during periods of grid congestion. These limits are typically designed around local congestion patterns. For example, reduced charging capabilities during midday PV peaks or reduced discharging capabilities during high load hours. For battery projects, this directly impacts revenue stacking and dispatch optimization. Sometimes other constraints, such as notice time, can be introduced, meaning that asset owners and operators are informed of constraints closer to real time, which makes them harder to optimize. In return, FCAs can enable earlier grid access and potentially reduce the Baukostenzuschuss. The Baukostenzuschuss is one-off payment to the grid operator to contribute to grid expansion costs. Let's take a look at how you can model your specific FCA setup in Gridcog, using an example collocated solar and battery project. In the base case, we assume a static grid connection. In scenarios 2 and 3, we implement import and export side constraints. In the base case, I have also included a separate Baukostenzuschuss charge. In the scenarios with an FCA, the Baukostenzuschuss is discounted. You can specify your own CapEx item here. Now let's take a look at how we specify the grid connection limits. Here I define the import constraint as a share of the grid connection capacity, with a reduced percentage during high load hours. This reflects periods when the grid is more congested and additional imports are more restricted. For the export connection limit, I have defined separate schedules for summer and for the rest of the year. During hours with high solar production, export is constrained by up to 90% in summer and up to 80% during the rest of the year. Looking at the results, we can see that in this setup, the grid export constraint has a larger impact on revenues. This is because in the base case, the solar plant exports to the grid, whereas in the export limited case, this isn't possible around midday. As a result, the battery compensates by charging more to absorb the surplus solar generation that would otherwise be curtailed. Energy project development is becoming increasingly complex as the energy system transitions, with new commercial structures emerging and additional operational constraints coming into play. If you would like to use Gridcog to model your own FCA options, whether you are currently negotiating them or have already received an agreement, reach out to Gridcog team.